Good morning and good evening, everyone. We've got a very international audience today. So good morning to those in the Northern Hemisphere, good evening to those in the Southern Hemisphere. Welcome to another Spring Innovation Showcase. For those who don't know me, my name is Carly Perry. I am Managing Director of Spring Innovation. We are the Innovation Centre of Excellence for the UK and Ireland water sector. So we were created back in 2021 for the benefit of both water companies and suppliers. So we're supported by all 18 water companies across the UK and Ireland, as well as the supply chain. So from small startups all the way through to large corporates. Our goal is to enable collaboration and remove duplication in the sector. So a very conservative average is that an innovation project happens 4 times, and there are benefits to be realised from centralising and sharing those projects to accelerate everybody's innovation journey. We also want to be helping suppliers have a faster path to value so that you're not knocking on all 18 doors and having the same conversation in the UK and Ireland, that you are actually able to come in through a front door through Spring, the Innovation Centre of Excellence. There's fantastic innovation happening regionally in the UK and Ireland, but also globally amongst the community on this call and further as well. But our goal is to connect those pieces of excellence that are happening and share those with a broad audience so that you can all learn. We're very excited that this is actually our first international showcase. So what we're looking for is if a solution is innovative and if a water company, whether they be in the UK and Ireland or outside of the UK and Ireland, has found a positive impact from it, we want to share that. Our vision as Spring is to be global leaders in open innovation, and this showcase is just a small part of our service offering to help us do that. For those who don't know, the UK and Ireland has a water innovation strategy. Spring is the custodian of that document, and the team will pop links into the chat of where you can find that document. But it was created back in 2020 to provide transparency around the challenges that the sector has and problems that suppliers can be solving. So that document has 7 themes in it, anything from customer to net zero to enabling future ready people. There's over 200 ambitions in that document, and we use it as a North Star for solutions that we're looking for to solve problems for the sector. The topic that we're going to talk about today is all around historical data to effectively predict leakage and enhance infrastructure performance. That relates to theme 3 in the water innovation strategy, which is all around resilient infrastructure. So you're going to hear a lot about creating resilient infrastructure today. Showcases, these 2-hour sessions that we do are actually a small part of a larger service offering that we have around knowledge sharing. And we've been partnering with Ofwat, who are the economic regulator in England and Wales, to build out a vision and best practice principles for knowledge sharing. We're going to be publishing more on that in the next few months, so keep your eye out for that. But we've been working with all water companies to build programs to help them deliver best practice knowledge sharing. So that means working with them from the beginning of a project to say who's the target audience, who will want to know about this knowledge, and how can we best communicate the knowledge to them. So we want to be seen as the centralised, trusted source for knowledge sharing in the UK and Ireland, but also beyond. And it's really fantastic to see such a global audience coming into this showcase today. All of the showcases are recorded and they go on to a library, which is located on the Spring platform. Again, the team will put a link to that library into the chat for you. This is showcase number 22. So we have quite a back catalogue now, and we've covered things from vulnerable customer to net zero and other resilient infrastructure pieces as well. So if you are really interested in resilient infrastructure, you can go into that library, search for previous knowledge and pass it on to teams. It's completely open and help educate you and the team. We've had close to 3,000 registrations for these showcases now, so they really are hitting a good sweet spot for people. And we've had over 100 registrations for today. We've actually had registrations from 12 countries outside of UK and Ireland today. So we've got representatives from Australia, Canada, Portugal, South Africa, Romania. So welcome to all of our international audience for today. I hope you find the session helpful. There's a real shift happening in the UK and Ireland around the culture of knowledge sharing, and it's great to see, and it helps with our vision to be global leaders in open innovation. But what's really important to realise that it's not just us transmitting and sharing, it's you receiving, embedding, applying that knowledge. So what's really important is that you listen for those nuggets that are useful for you today, but then you go back into your business and you take them and you action them to help accelerate your journey. So with that in mind, I'm going to give you a quick rundown of the agenda for today and talk through the presenters and then hand over to the team to get into the good technical pieces of information that you're here for. So after I've introduced the speakers, we'll hear about the importance of knowledge sharing and why we are all behind sharing our efforts, introductions to the companies involved, the essence of data-driven asset management, asset performance optimization at a Netherlands water company, data-driven asset management at an Italian company, data-driven asset management, a deep dive into it, rapid leak detection, and then we'll go into a break and questions and answers. So you can use the functions that the team are sharing in the chat to ask questions throughout. And at the end of this, there will be a panel session Q&A for you to be able to get your questions answered. So it's a jam-packed agenda. Very excited to hear more from the team. In just a second, I'm going to hand over to Hein Molenkamp, who is president of Water Alliance. It's worth noting that the two water companies that are with us today, so one from the Netherlands, one from Italy, are actually going through a transition of CEOs at the moment. And so we weren't able to get a senior representative, but that's no reflection on the commitment to this project. But Hein Molenkamp is here to represent Water Alliance and to give that view of how important knowledge sharing is and this work in particular. Proud to say that Spring and Water Alliance are starting to collaborate more on how we can transfer adjacent innovation from the Netherlands into the UK and Ireland. So watch out for more in that space. We'll then hear from Ignis Worm, who is co-owner from Spatial Insight, our supplier today, who will share more around the solution that we're talking about. And then we have Nino Marino, who's specialist asset management at the Netherlands utility, who have been working with Ignis on this solution, as well as Flavio Battagnin from GSP, an Italian utility, who is an expert in water supply system development, and again will give you experience from an Italian company perspective. So that's everything from me. Enjoy the session. I am going to hand over to Hein from here, and I'll be in the background listening away. So thank you all. Enjoy.
Okay, good morning all to you. Also from my side, the Netherlands, and Kali, thank you for the introduction. I fully agree with you. That's very important to share knowledge and collaborate on many fields. There is so many challenges in the water space that it is very important to team up, and that's why we also have this good context with you in the UK and Ireland through Spring as well. I'm managing director of Water Alliance from the Netherlands. We are a association of 200 plus members, and they're all active in the field of water technology, so to say. Water technology is an interesting space, of course, because water all connects a lot of sectors. And of course, we are here focusing on all applications into utilities, but we also have much members who are active in other fields of operation. And well, that's why it is important to collaborate if we want to speed up to implement new and innovative water technologies. So that's also why Water Alliance is running a program in the UK, for instance, to to set up these type of collaborations. And today, the showcase of Spatial Insight is one of those examples in this showcase with Spring. So a little bit about to innovate, to get to new innovations. In the Netherlands, Waterlines is part of a rather interesting eco-innovation system called Water Campus. At Water Campus, there is set up a whole structure in the last 20 years where we try to speed up new innovations from the first idea to the implementation in the market. And as you all might know in this field of operation, that a lot of technologies, they take probably more than 10 years before they are really put in action and practice, because there is a lot to do from research side up to scaling up the technology and demonstrate it and then have it in full application. So at Water Campus, there is a collaboration between research institutes and all kinds of educational institutes and other associations like Water Alliance. As Water Alliance, we are focusing on the market side. So our members are, in fact, all members who are in the market space and bring their technology either to the Dutch market or to global markets. And as you know, the Netherlands is a small, tiny country, so export is a really important thing. And for that reason, we also team up with Spring in the UK. And I'm very happy to introduce Spatial Insights in this showcase today. So far from my side, if there is any questions to connect to other technologies, I'm always open to connect, and you can take contact with us, and we will see if we can connect, and hopefully to the Spring organization as well, of course. So far from my side, if there is any questions, please pop in chat, and then I'll give the word to the next speaker, Ignas Worms of Spatial Insights.
Thank you, Hein, for your words. And yes, we are a proud member of the Water Alliance Spatial Insight. So thank you for making some time this morning to welcome us. Yeah, just a short opening. I'm very pleased to introduce Spatial Insight. My name is Ignas Worm. I'm co-owner of Spatial Insight. Some of my colleagues are in the call as well, and on the chat, Arnaud Refijn, one of the other co-owners, willing to answer any question during the presentation already. Very pleased with the contribution of Flavio Bertagnin from GSP Belluno. And Nino Marino next to me. We are in the offices of Oasen. We're guests here today. That's really nice. But I think I give the floor first to Flavio to do an introduction. First to Nino for an introduction. Please go ahead, Nino.
Good morning. I'm Nino Marino, and I'm a specialist asset management at Oasen. And Oasen.
Yeah. Oh yeah, maybe we should control the slides, or otherwise.
Yeah, just press that take control button.
Oh yeah, there we go. Yep. Excellent. Yep.
Now you should be able to move the slides forward.
Ja. Linksom een pijltje.
Ja, het mag.
Ja, prima.
Oasen is a small water company in the middle of the Netherlands. At Oasen works. We distribute drinking water through 360,000 customers and through 4,000 kilometers of pipelines. At Oasen works some 300 employees. Our new CIO, Arjan Driespoor, starts tomorrow, so he could not be here. And we produce 45 million cubic meters of water every year, and we have 14 plants, and we use two ways of purify the water. firstly among with sand and air and the traditional way, but we also have 3 plants now which use reverse osmosis, which result in 100% pure water. And we replace 40 kilometers of pipeline every year. We predict pipeline breaks, so we know which pipelines we must replace first, but later on more about that. We have about 200 known pipeline breaks a year, and our non-revenue water is 4.7, and we want to go to 3.7.
Okay, thank you, Nino, for this introduction.
Yeah.
And I'd like to hand over to Flavio. So Flavio, if you switch on your camera,
Yeah.
I will go to the next slide if you ask me.
Okay, just a brief introduction about myself. My name is Flavio, and I'll now give you an overview about the GSP company I work for and some further details about what we are managing and which are our criticalities, and of course why we decided to embrace asset management and starting a collaboration with Spatial Insight. So I have to say that despite we have been operating for over 20 years in the water cycle management, only in the last years we became aware of a need of a technical improvement to cope with the pipe aging and to be honest, also due to the incoming rules and performance targets from our national regulators. So where we are. Speaking of our company, GSP, it runs the water cycle in 58 municipalities in the province of Belluno, in Veneto region, northeast of Italy. And our company has been operating here for 20 years. And it's a completely public utility with its headquarters in the county town of Belluno. As you can see in the frame on the right, there are some more figures to better understand our size, not that big. As you might see, for instance, most part of our municipalities are under 3,000 people compared to a very wide territory of 3,500 square kilometers that leads to a very low population density, and it's itself a criticality in our business. Next one, please, Nicholas. Can you switch? Okay, previous one. Okay, perfect. So in this depiction, you can see the facilities we manage for the whole water cycle. They are dimensionally small, but in numbers are pretty big, as you can see. I have no time to go through all the facilities in the picture. I just want to highlight the length of the network of almost 3,400 kilometers without connection. And I think that in this context, the two more interesting numbers to look at are the total inlet volume of 68 million cubic meters and the revenue water at 13.3. So that's clear that we have a very high non-revenue water problem, and we absolutely must reduce it in the coming years, adopting a set of proper technology and hopefully keeping an asset manager approach like we are doing now. That is what we manage daily. And to conclude this introduction, I'll tell you some of our main criticalities. Well, the first one is the number of boiling water notice we have in the minor springs all around the mountains, generally when it rains heavily. But the most important issue to address, as I said before, is the level of leakage in the network. I mean mains and connections together, where the total water loss is at 68.3% at the end of last year. Another problem, actually linked to the previous one, is the level of leakage in the connection that becomes harder for us to solve since we have pretty all the customer meters installed on the private property and often directly inside buildings. And finally, we definitely need a data-driven process to select the pipes to be replaced in order to increase their effectiveness and maximize the impact of our investment. And that's why we started a business relationship with Spatial Insight. Also thanks to our major ongoing project that has been funded by European Union in January 2023, and about which I'll give you some details later. That's me for now. Thank you very much.
Okido. Thank you, Flavio, for your clear intro. Then let me do 3-4 slides on Spatial Insight, on the introduction of our team, before going into the content of the approach. So we are a team of 11 by now. Majority of us have worked for utilities before, so we know the utilities well from our own experience. And we have a mix of, in fact, what our team is representing, that we are bringing together 3 fields of expertise. We are bringing together GIS knowledge, data preparation knowledge. We are bringing together data science knowledge and asset management knowledge, so domain knowledge. And in this sort of crossing of those 3 fields of expertise, we develop our software. So very pleased with this great team. And also what is interesting in perspective of this morning is that the Netherlands is really well performing globally in terms of non-revenue water. Now, of course, we have a very flat country, so the pressures are relatively, compared to more elevated countries, are relatively low. But still, we have, as Nino already introduced, Oasen is quite representative, I would say, around 5% of non-revenue water, which is really low, which can also not only be explained by the low pressures, but also by the fact that we in the Netherlands, we have this sort of proactive approach where we like to replace stuff, not only water pipes, but that applies to bridges and houses and etc. We like to replace things before they break, which you could say is quite silly, because why replace something that is not even broken yet? But this very proactive approach leads to these really, really low non-revenue ratios. And within this already well-performing industry, we serve the Dutch utilities, and we are really close to being awarded with the 10th Dutch utility awarding us a project. So then we are delivering services and software to all Dutch utilities, and as you can see here, but also clients in Italy and in Austria, but we're also, I'm expecting soon to start serving a company in Belgium. So we are really also getting used to delivering our services internationally. We are based in the Netherlands. Always welcome to visit us when you're in the Netherlands. We are only 30 minutes from Schiphol, 20 minutes from Schiphol by car, 30 minutes by public transport. And you're always welcome to, well, get along and drink a coffee or meet us in Haarlem. Right, that is the introduction of Spatial Insight, and then I like to move forward to the content of our presentation, the essence of data-driven asset management. And when it comes to, let's first have a look on water losses in general and how to prevent them. And then I'll make a step to the asset management, wider asset management approach before introducing the different approaches that we have into these two frameworks. I assume that some of you will recognize this four-pillar approach. It is has been published years ago by the IWA Water Loss Task Force, and this is a framework of the four different aspects to reduce non-revenue water. So on the top hand, the pressure management, the reduction of pressure is a very powerful and smart way of reducing non-revenue water. Repairing leakages, active leakage control, and on the bottom, this pipeline asset management. And today we are, although Nino, you will be presenting about smart meters as well, but the presentation will focus today on the asset management side. And so we are aware that asset management is not a holy grail. It is part of the wider solution to control non-revenue water. But I think it's a very necessary way and very useful way of contributing to non-revenue water. Okie-doke. Then some of you will also recognize this diagram. This has been published by the Institute of Asset Management, and this is, in fact, what this it comes from the ISO 50001 international standard on asset management, and it shows, in fact, what this picture shows. Of course, in the middle, this blue asset life cycle. From acquirement of a new pipeline, the operation, the maintenance, and the disposal. And this is, of course, an ongoing in our centralized drinking water supply. This is an ongoing cycle. We continuously maintain pipes, dispose them, and replace them by new ones, as long as we have a centralized water supply, which is most likely to continue for the coming decades. What this diagram shows is that asset management is a company-wide approach. This is not an asset engineer in his office making clever calculations. This is about the board of the company setting targets and objectives for the performance of, in this case, the water distribution network. This is about the people in the finance departments. This is about the people out there who are actually fixing leakages and replacing pipes. Everyone, this is about the GIS expert. This is about the ICT department who is preparing and facilitating the solutions. So everyone is in fact, everyone, especially in drinking water supply companies, everyone is involved in asset management if you look at it from that perspective. Now, as Spatial Insight, we are focusing on this asset data, the asset information side, on the asset management decision-making process. And this helps, this is input for the multi-year, long-year asset management planning and investment planning. So that is where we as Spatial Insight contribute to asset management. What we try to do when we think, we do quite a lot of product development. In the Netherlands, we are really privileged with utilities that are really closely working, teaming up with technology companies like us in developing new products, new algorithms, new services. And so when we think of our roadmap, when we're making the decisions in product developments, we've always tried to think about the responsibilities of the asset manager in the water utility. And we think these are the 4 steps that he or she is going through in his responsibilities. So it all starts our approach with integrated data, with uniformed and integrated data. We will be talking about asset data and failure data mainly. Then the first step, when the data is there and when it's available, we're going to do objective analysis. These are, you could say, black and white calculations. There's an input, there's a calculation, and there's an output. Then when we have created the insights, factual, objective insights, and in the next step comes the decision-making process. And this is where the human preference comes in. This is where the company policies come in. This is where we facilitate the asset manager in running different scenarios, investment scenarios, and enabling the asset manager, who is often a technical expert, to have the dialogue with the board or with the shareholders on these investments, which are always quite substantial. And then in the final step, we all are also aware that even when you have done this process optimally, then still, this does not mean that you can execute the projects that you have calculated. The other people, other organizations are working in the underground as well, like the municipalities, like the energy companies. So we are aware that in this final step, the alignment with other organizations is taking place, and also that the design of the new network, so what is the optimal diameter to put in the ground. And as you can see, in all these different steps, we have software and services, or some of these we are still a developing company. Some of these algorithms that you see here are available as software. Some we're running in sort of subscription way that we do apply the algorithms manually, but we are in this transformation. More and more, all of our knowledge and algorithms is transferred into software, which will enable our end users to do these calculations themselves. So today I will be focusing on those number 1, 2, 3 analysis, regression analysis, cluster, and rehabilitation. So this is not an Amy Winehouse sing-along. This is really about rehabilitation of pipes. And then we go to the BestNet, the decision support tool. Okay, just to visualize in the way that we at least consider our way of working, is that we start with asset data, failure data, and some additional data. What you see here, what you actually do not see here, is settling data, is condition data, is satellite images, is monitoring data. And this is very deliberately because in our vision, when any of these aspects, like settling, like traffic, like any other aspect, would impact the network and would lead to leakages, it will have led to leakages. So and this is somewhat trivial if you wish, but on the other hand, it's very powerful, because when you have a proper failure registration, you can do amazing things already and create amazing insights without any investments or any OPEX in the acquirement of those additional data sources. Now, I'm not saying that these additional data is not beneficial or useful. And as soon as our clients tell us, now we know a clear relation between condition assessment A and failure rate, then it's very easy for us to include it in our methods. But so far, we believe that the historic leakage data is the most powerful predictor of future leakages. And that's why we have built up our software and solutions around the already available data in many utilities. And I will talk about data quality later on. Now, then we have this sort of base plate of data, and there we start building our building blocks. These two tools are probability models, two different approaches to calculate the chance of failure of a pipe. Then by multiplying the chance of failure with the effect of failure, we come to risk for each pipe segment. And then in the following step, we will be doing this decision support. So there we will be enabling the user to compare different scenarios, combine different models, because that's what you're seeing here, this orange block. BestNet, our tool, enables to combine different risk models. So you can merge. So you don't need to have SI Rehab before going into BestNet. We are really excited to actually include the existing risk models. And as I will show later, you can manage and merge those models in your own models and different new models in different ratios. Very powerful part of BestNet. Okay, our colleague Roy who's our best looking colleague. We didn't recruit him for his looks, but he said this is a great picture. Well, let's first hand over to you.
Well, thank you.
I will help you out with the slides.
Now, I'm going to tell you how we replace the right pipelines or they will break. And in the past, we are using the decision report software for many years. And for the last 5 years, our focus and money went to purify the water with reverse osmosis. And therefore, we replaced less than 1% of our pipelines. And we saw that our non-revenue water percentage increased. Also, we had a knowledge drain. And in this graphic, you can see the results that study of the increasing of numbers of leakages. But today, we are changing the focus again to asset management. And we are using all the software and services of Spatial Insight. And also, we are integrated more and more data in our data warehouse. Recently, we implemented the risk model. We started, we have implemented now the geographic data warehouse from Spatial Insight, also known as Asset Data Integrator, the blue box in the middle. Now, the green boxes you mentioned in the former slides. And recently, we have transported data from the Asset Data Integrated in our digital twin from Schneider. And we are going now to insert the data of our smart meters into the Asset Data Integrated and then put it in our digital twin. And on the map, you can see the pipes we must replace first in that specific area. The darker the line, the higher the priority. And now we are in control with respect to non-revenue water. The red line is when we replace 0.8% of our pipelines for 8 million. And the blue line when we replace 1.25% of our pipelines. And so you can see that when the red line is increasing and the blue line is really steady of our breaks. So that is my story, I think.
Thank you, Nino. Yeah, it's a great example of the insight, and this also facilitates the discussion, the dialogue with the board on the annual investment program.
How much will you replace and invest?
Yeah. Okay, though. Thanks so much, Flavio. Can I give you the floor to talk in more detail about the approach that you're following in Belluno?
Okay. Well, as I mentioned in my previous introduction, you can switch to the next one. Thank you. The collaboration with Spatial Insight, in our case, was born out of a project we made in 2022, and that has been funded by European Union, which purpose is the reduction of losses in water networks and the network digitalization and monitoring. On the picture on the right, you can see the involved area, which is a portion of the province of Belluno in yellow color, where we have a total of 115,000 inhabitants. As for the budget, we have 20 million euros funded out of 25 of the whole project. This fund came with a very challenging due date, that is the end of 2025. And it's a very short time, because we started from scratch just 2 years ago, and it comes with two demanding targets, which are the first one is comes from directly from EU and consists in the setting of DMAs in 1,600 kilometers of network, and this is absolutely mandatory for us to have this fund. The second target is national and consists in the reduction of total losses by 35% compared to the 2020 baseline. That in our case was at 73.4%, and now, as I mentioned before, we are a bit less, 68%. To accomplish these two targets, we have planned many activities like hydraulic modeling, DMAs, designing, active leakage control, and pressure management. That is absolutely important in our territory, with high differences in altitude and high pressure, sometimes even at the customer meter itself. Other activities are GIS, SCADA improvement, and customer meters renewal with smart devices. And finally, the development of an asset management strategy and of a process for data augmentation in general. Next one, please. So, having said that, the reason why asset management is so urgent for us is because our project framework allocates between 1 and 2 million euros for structural replacement of mains, but the EU put a mandatory restriction that the cost of each replacement can only be accounted for if the choice of pipeline is data-driven. And it's clear that with so short time, the strategy couldn't be based just only the modeling activity, which takes a lot of time, especially starting from scratch as we did, because we did not have any hydraulic model when we started this project. So here came the solution of Spatial Insight, which has been allowing us to make the most simply with what we already had. For instance, we had a good GIS platform with a pretty good topology, even if with some errors. And we knew the age of the pipes, at least partially. We had a short but a good historical data set of fixed leaks extended for 2 years. So we had a few strength points to rely on, and let's see with them what we did. Next one, please. In the first place, we shared with Spatial Insight the main information about our network geometries, like basic data like material diameters, age were available. And basically, we gave our geodatabase to import in their systems, and it was fairly simple and a quick step. Next one, please. Okay. After that, we were able to process our data and gave us some feedbacks, especially about topological errors. So we were able to fix them. maybe also double checking directly in the field to survey some places where there were some major doubts. Next one. As a first step, and sure the most important one, we shared all the data we had about leakages, like position, the date of fixings, and so on. It's worth to note that 1 year ago, thanks to a workforce management tool that we were already using, we had only 2 years of data, more or less, and still these data were enough to start. So putting all these 3 main steps together, after 12 months, we finally could have had our data analyzed. Next one, please. Okay. In fact, Spatial Insight made a first iteration of analysis running their 3 modules. I have highlighted here in the slide, but with some explanation, but Ignaz will explain you way more clearly than I could do. So we can move to the last and the conclusion. What we obtained is the risk assessment map of our whole network that you can see in the big picture. There's our province in the background and some highlighted segments of pipeline. The ones in magenta color have a higher risk index and should be replaced with priority, of course. So to conclude, I could say that as for our project, we have been able to start replacing a small section of network in compliance to the mandatory requirement of European Union, and without having to wait for all the hydraulic models to be done everywhere. And now we are ready for a second iteration with improved data. And finally, we are looking forward to the next step, I hope at the end of this year, when we will be able to apply BestNet software for decision support in the long-term investment planning. That's me.
So yeah, excellent. Thank you, Flavio, for your very clear overview. So I'll speed up a little bit, taking time into account, but let's deep dive in more detail into the different approaches that I introduced. So this is where we ended before addressing the cases of Oasen and GSP, the base plate and the different analysis and the decision support tool. Well, let's have a look at the regression analysis. What the regression analysis is doing is finding the relation between the age of a pipe and the failure frequency. Find the failure frequency as a function of the age of a pipe. And we can do this for the complete population of pipes, but also for different cohorts, let's say for PVC only, or for asbestos cement only, or specific ages or specific categories. This is very useful because this gives you a first impression on the failure frequency of each pipes in the network. Very basic, very straightforward, although already this is where domain knowledge comes in. So because in this on the right hand side, there will be more diffuse data points. So you need to be aware which data can be taken into account and which ones cannot be taken into account. Let's have a look at this demo. Let's see if that is all working well.
I think you just need to press play, Ignaz.
Okay, makes good sense. Yep, there we are. So this is how it looks like in our platform, SI platform. Here you see an example of the data plotted for a specific material, and there the line is fitted through the data points. And also you can see, if you as an expert, you see, well, let's take into account a specific part of, I don't want to take these red ones into account, then you can select manually the data points that you want to consider and that you want to take into account for this regression, for this fit. So this is a way to calculate the first insights in the probability of failure in your network. Then we go to the next one, because this is now we come to an interesting point where, go back one slide. An interesting situation here is that these are two examples on the left-hand side and on the right-hand side of a PVC pipe, 3.4 kilometers long, 110 millimeters from 1960. So two similar pipe groups of pipes, if you wish. Then in the middle, you see the regression analysis. And when you take this regression analysis, it shows an average failure rate of 0.057 failures per kilometer per year. But on the left-hand side, you see that in this example, there are 12 failures in 8 years' time. And on the right-hand side, 0 failures. So now what should you do? What should you pick? Should you pick this average, which is true in a way, but not really relevant in both cases? So this is the second way of calculating the probability of failure, is by this cluster analysis. And here we merge pipes with similar characteristics together and calculate a failure ratio for each cluster in the network. So this, and we the title of the slide, we take the local unknown factor into account, because there must be a reason why the left-hand side has more failures than the right-hand side. I guess when I look at this picture, it will be something like an urban area on the right-hand side. Maybe there's a lot of traffic, and the right-hand side may be a more rural area, for example. I don't know, but maybe it was a bad batch of PVC on the left, or it was a bad contractor or settling or whatever. But we say, for this analysis, we're not interested in the reason of failure, but we simply acknowledge that failures occur, and most likely new failures will occur on the left-hand side more than on the right-hand side. So now we have two ways of calculating the probability of failure. And this was the picture that Flavio was referring to. We see, and Flavio asked us, so now we have those clusters. We know those weaker points in our network. But if we want to not replace all those clusters, can we even focus within a cluster? And this is the orange circles are a very basic way of focusing on putting a spotlight on the areas within a cluster that are worse. So even if you want to focus your investments even more, and also I know that GSP prefers to have smaller projects. In the Netherlands, typically we are used to replacing kilometer or so of or even more. When we need to have a contractor out there, let's do a bigger size projects. But in Belluno, the preference is to do smaller projects, and this is a way to focus on smaller projects. Well, in this first iteration that Flavio was mentioning, we identified the 5% of the network responsible for almost half of the leakages in the network. And this is really helpful, because this helps you to focus not only your investments, but maybe also your inspection efforts or other activities that you want to do in the network. This is really bringing up the places in the network with the highest chance of failure. Then we come to the next step, where we're going to include the effect of failure. And so in the end, effect plays a role, because we have, well, not recently anymore, a couple of years ago, we had a hospital in Amsterdam. It was complete. It needs to be evacuated completely. Hundreds of patients needed to be taken out of this hospital because a transportation line was breaking and was flooding complete area. So it was a nightmare. So just as an example, how important the effect of failure is. And we have two ways. I won't go into too much detail. We have two ways of calculating the effect of failure. Internal effect. So if a failure leads to a less performance of the network, we consider this to be an internal effect. For example, this is an example of the dependency of a section from other sections. And so some sections at the end of the network will have less impact than a section in the beginning, let's say near the pumping station. Other sections may depend on this specific one. But this is just one. We also calculate the number of connections, the customers minute lost, all kinds of internal performance that is being affected by a leakage internally. But also just this example of this hospital, but in this, you see in this picture, you may say for highways or railways or all kinds of infrastructure that is being damaged by a leaking pipe, you want to take this into account. So we're going back to SI platform, our platform where all these different software modules are available, / will be available in some cases. And here you see a map with the results of SI Rehab. And when you start zooming into this into these results, then the different graphs on the right hand side automatically are being updated, so that you, for any specific area in your supply area that you're assessing, you can see the specific risk values or chance of failure values on that are happening. And also when you click on a pipe, you get all these different aspects. So this is then how we end in these kinds of typically we hand over data sets back to our clients and they view the results in their own GIS viewers. We have our own viewers as well, which we offer in a cloud, let's say online service. So we have clients who prefer to have software as a service. So we can also offer these sort of browser where you just have your own browser and you can see the results there. But we also hand over complete data sets with all these detailed results. And there you see the chance in yellow, had a chance of failure, the effect score, and that together multiplied is the risk score. So then we have these insights. Then we know what objective actually what is happening in the network. Then we're going to make decisions. And in BestNet, which is our decision-making software, that is software already available and running at 5 different Dutch utilities, including Oasen. And we're doing a pilot with a 6th Dutch utility. And this BestNet exists of 3 different modules: the combiner, scenarios, and project builder. Well, first, now go to this combiner. So when a lot of utilities, and I assume a lot of British and Irish utilities, will have their own replacement models, self-developed from universities, commercial, and of course, every model, in general, every model is a representation, a simplification of reality, and which is very useful because that you actually have something to represent, to calculate, to estimate how the reality works. On the other hand, there will be shortcomings in every model. And by merging different models, we assume and we think that you can create a more robust, a more representative model than the individual models that you have. And this is an example of the user interface of BestNet, where on the left-hand side, we will also see this in the demo. You see the different ratios. You have sliders where you can choose the ratio of each model that you want to include in your calculations. So you can also play around. You can assess the effect of using one model compared to another model, and get feeling of the sensitivity of each model. So you combine different models into your optimal combined model, and then you go to the next phase where you will define scenarios. And as you can see on the left-hand side, you see this 1.25% per year. This is the replacement ratio. So this helps you to draft the slides for the board, where you can say, okay, if you want to reduce your investments in network, that's perfectly fine, of course, but please be aware that this is the leakage in the coming 3 decades. This is how the leakages in the network will develop, or this is the average age of your network. It will increase when you invest this amount of money. And this is really, really interesting. And we had one of our clients in Rotterdam. He used this to make a presentation for the board of his company, and his director, she decided to pick the most in fact, the most expensive scenario out of 3 scenarios, which is quite remarkable. Typically, CEOs pick either the middle one or the cheapest one, but he managed to make clear what each investment, what the consequences of each investment level what the consequences would be. Okay, so now we're going to have a look at BestNet. There we see those sliders, sliders, and you can pick the different models. In this case, Rehab Cluster in Somaseo, which is a local model of a client. Oh, this was too quick. Let's go back one more time. Yeah, back again. So going to BestNet, in the BestNet combiner, in the first module, selecting the different models, selecting the different ratios, calculate the results and save them. In the scenarios, you can go back to the initial data set that you want to use. And here you can have different settings. You see this repletion success rating, which is a way to say it will always be very hard to only replace the worst pipes. We know there will always be younger pipes that are sort of included in a project, and this is to decide upon the level, the success level that you want to have in your calculation. Let's see if I can let it run again, the demo, this short movie. Maybe I can click forward manually. It seemed to have stopped. Anyway, what we see here is all these different graphs that are, like in the previous slides, all these different examples, all these outputs, different outputs that are, you can see 2 outputs here, but there are many more, and these give insights in your performance. And then in the final step, the project builder, you will merge all those individual prioritized pipes into projects of the size that you prefer. Well, we are engineers mainly, and we are most excited by new problems, new challenges, new stuff. So we can't wait also to dive in more, do more and more, and specifically for the more elevated countries like Italy and Austria, where we're active. We are including hydraulic insights, so pressure as part of a failure mechanism into our calculations, and we're also making the step to design fully automated design of the pipes in the network. Nino, can I give the floor back to you?
Yes, you may. We believe that preventing is better than repairing leakages. But when you have a leakage, or a pipe burst, you want to repair it as quick as possible with data for direct insights and local level. The next, please. And the current way of leak detection is using DMAs. We also did that, using until now 40% of our pipeline network contains a DMA, with in total 70 sensors, and we spent until now 1.5 million. Last year, we started for looking for an alternative because our business case was not positive anymore. So we bought 250 smart meters combined with a PI box, and with the PI box you can measure the pressure, and with the valve in the PI box you can regulate the water supply. And the smart meter has an acoustic leak detection sensor in it. And we at first we installed 75 smart meters in a small town, and we simulated a leak outside the houses, and the smart meter detected the leak at 150 meters, and the AI software located the problem at about 20 meters. A very good result, I believe. And inside the houses, we detected also leakages. The graph is below shows a constantly flow of 4 liters per hour, also during the night at the customer. The toilet was constantly using water, and we had a happy user again. And go further. Our conclusions are for this part. We estimate a reduction of our non-revenue water with 1%, and acoustic detection is very successful in towns. You don't need the PR box for leakage detection in towns, but we are going to do other use cases in rural areas, and I believe this use case is very good alternative for traditional DMAs. Yes. So most of our use cases were successful the last 5 years. We did a lot, and when you see an opportunity, go for it and learn for it. And that's our motto. Thank you for listening.
Thanks, Nino, and we are really pleased to be so closely connected with Oasen, and you are sort of running ahead in all those developments, and it's really you're really inspiring us also with this whole smart meter approach. Is really clever, and we are also very excited to see how we can sort of embed all those insights also in the asset management prioritization. So we're really pleased and privileged with this great developments. This is my last slide, Leah, before handing over back to you. What we are looking for, what we want to do is invite the utilities that are present today to start working with us. Now, we are aware that it's not so easy to sort of send your data to a Dutch relatively small company and get results that tell you what to do. So trust is crucial in when it comes to asset management, when it comes to those data-driven solutions. Of course, trust is crucial. We have been thinking about this, and what we think is the best way to be trusted is to gain trust, and that's exactly what we want to do. So we offer to do a free demonstration calculation with SI cluster, with this cluster analysis and this hotspot analysis, and this is a way for you as utilities to, well, hopefully with a very low barrier, get to know us, assess us, experience us, and hopefully appreciate what we're doing. And then, of course, when you think that we are sort of being able to help you out, then of course we're looking forward to make next steps. Of course, when you are convinced already after this first hour, then we can of course step up and do pilots or full implementations right away. But please know that we are very pleased and very willing to do a demonstration free of charge for a reduced part of your network, for you to sort of get to know us better and to assess our capabilities. So thank you for your time today so far. Leah, can you take over again and take us further?
Of course, thank you, Ignaz. Sorry to the audience, I'm a little bit ill today, so sorry for any coughing or spluttering in advance. Thank you all to the team so far for a brilliant presentation. I think they've covered some really great ground there on this technology, and so we'll just be going to a quick 10-minute break now, give you all a chance to get yourselves a drink and pop to the toilet before we come back and we go into our question answer session. Please do feel free to keep putting your questions into the chat while we're away, and we'll do our best to cover them all when we come back. So the time is now 11:10, and we'll be returning at 20 past to continue with today's session. Thanks, everyone. Okay, so hopefully we should just be returning from our break now. I'll give it a few seconds for our presenters to rejoin us and get their cameras and mics turned on, if everybody could, please. Perfect. Hi, Ignaz. Hi, Nino.
Hi.
Hello.
Flavio, are you there?
Yeah, coming.
Perfect.
Okay,
so I am just going to stop sharing the presentation now so that we've got more room for our lovely presenters' faces during this panel session. Perfect. So welcome back, everybody. We will be going into our question and answer session now, but please don't feel like you have to stop asking your questions. You could keep popping them in the chat throughout this entire session, and we will make sure to ask our presenters your questions. If we don't manage to get around to answering all the questions today, we'll be popping the unanswered questions up along with the case study on our platform after today's event. Perfect. So without further ado, we have a first question, I think for Arnold would be a good person to answer this, from Jeremy Heath, who has asked, have you looked at different failure models? In the UK, we treat failures that occur due to ground movement, for example, freeze thaw or summer dry out, as different from failures due to pipe condition and pressure surges.
Yes, thanks for the question. In our models, we try to combine the failures with all causes, because often they are a local effect, a location that will be affected by drought, will be affected in the next dry season as well. So the occurrence of a leakage with a certain cause will also predict that it will happen again in the future. So in our models, we combine the failures of all with all causes, except of course the ones caused by third party, because that might, if it's due to construction work, it's not likely to happen again.
Perfect. Thank you, Arnold. And the next question comes from Adrian, who has asked, from the example shown, it is looking at smaller networks. Here in Ireland, we manage a network of over 64,000 kilometres. How would Spatial Insight tackle such a large network efficiently?
And the answer is, allow me to answer, Lydia, that for us and for our software, the size of the network and the amount of data, in fact, is not important. It's not relevant. We can, it will take a few seconds longer to do the calculation, but the approach is similar. The models are similar. So in fact, we love the bigger the data set is, the more data we have, the statistical value increases. So in fact, we're really pleased with larger data sets in terms of asset data as well as in terms of failure data. And we can, as Flavio mentioned, with 2 years of failure data, we can make an initial run. But if we can choose between 2 years of failure data and 10 years, then obviously we choose 10 years. So the larger the data set is, the better the results will be. It will take only limited, negligible amounts of longer calculations. And also this is also reflected by our price model. So we don't have a price per kilometer price model, but we have just a price per client, per supply area. So we have one price and we do the complete supply area for this same price.
Perfect. Amazing. Thank you. So it almost works out better if we've got a bigger company then in that sense.
Yeah.
Amazing. Perfect. So another question just coming from Jeremy is, in Italy, so Flavio, I think this might be one for you. How are you infilling the missing GIS data? The pipe material is vital in understanding failure. Have you looked at using property, age, or any other data sets to estimate pipe material?
Well, Mike.
You're muted.
Oh, sorry.
Flavio.
Could you rephrase the question, please?
Yeah, sorry, do you want me to repeat it? So in Italy, how are you infilling the missing GIS data? So Jeremy has said the pipe material is vital in understanding why failure happens. Have you looked at using property, age, or any other data sets to estimate the pipe material?
Yeah, that's a huge problem with our data set. Of course, our data lacks some information. I say especially the age of the pipe, and we worked much in the last few months to try to enhance this type of data. Searching from past project, looking in the archive in our municipalities offices, and this kind of work that it takes so long time to be accomplished. and that's for the age. For the material, now we are forcing our colleagues on the field to a better use of our work management system to gather data from the field. I say when they go to fix a leaks or to dig a new chamber, or in any occasion, they go to the field and see the network. We ask them to write down new data, and they have a tablet with themselves in which they can see our network and the data, so they can see what lacks, and they know what data we need. They have to replace. This way, we hope to improve the data about materials.
And allow me, Leah, to add to this. So this data quality or data quantity, if you wish, but this issue is very common. And we say in fact, every utility, there's no utility with perfect, complete data. And this is a bit of a sort of chicken and egg. If you don't have sufficient data, you may think we cannot start with modeling because we lack sufficient quality of data. But on the other hand, if you never model, there will never be an incentive to start improving the data. And with the GSP, we have really an exemplary way of cooperation where we do an initial run with data. It's not ideal. No, it's not ideal. It's not perfect. But we made an initial run. The results were actually already useful. Not perfect, but useful. But we handed over the suggestions for improvement to the team of Flavio. They increased the quality of the data. In the examples that Flavio gave, we have better data now. The next run will have better results. And this is, I think, I hope that people are not discouraged by the fact that the data is not perfect or optimal. We encourage people to actually start making these runs, and then also have a reason to go back to the board to ask for investments in data quality. It's a chicken and egg, and either pick the chicken or pick the egg, but let's not ignore both. That's our sort of suggestion.
Yeah.
Perfect. Thank you, Ignas. Does anybody have sort of anything they wanted to add to that? Nino, did you have anything from Oasen's point of view that you wanted to add to that at all, or? No.
No.
Perfect. No, that's fine. So Ignas, one for you. Sorry, I've lost my train of thought. How would Spatial Insight deliver the software and services in the UK and Ireland versus in sort of Netherlands and Italy?
Yeah, and well, in fact, that really depends on the preferences of the utility. So in Italy, but also in the Netherlands, to be honest, in Belgium, we have more and more clients that request software as a service, because the ICT departments, due to all kinds of legislation, are more and more strict and really limiting the adoption of new software. And then the crazy situation occurs that they say, well, then they prefer software as a service, where they just have a browser that they can engage with, because it's so nerve-breaking to install new software. So we see an increase of utilities that request our solutions as software as a service, which means we have our Azure servers, Microsoft Azure. We install the software on that on our servers. We add the data, so the data is being transferred to us. We make the calculations and we give back the results as data sets and the screens, the visuals, over internet. But we are really, we move where the client wants us to move. So we also have clients in the Netherlands in particular. We have 6 out of the 10 utilities. There we have our own server within the domain of the client. So we have remote access to a server in the utilities cloud domain. So there we work in the cloud, but then on the client's cloud. And we can also do this on premise. We can install software locally, but this, of course, is something that we do not encourage, because it's the handling of updates, that requires traveling, and it's really tough, more and more tough to do this, to comply with the data security policies of the utility. So, well, that's it. We can do all. we definitely prefer cloud, and then either our cloud or the cloud of the client. That's up to the preference of the client.
Perfect. Thank you, Ignaz. So just another one coming from Jeremy. A large amount of leakage occurs on the communication and supply pipes. Are the models able to look at the potential for these to fail as well?
Yes. The models we presented today, they basically focus on distribution network and less on house connections. Though house connections are a large, in many places that they are responsible for about half of the leakages. So we are busy developing a separate model looking at house connections especially, and also one that is more focusing on transportation. What we've seen today mainly focuses on distribution, and well, we'll be working on the other subjects and probably be somewhere later this year it will be finished.
Oh, amazing news. Perfect. Okay.
And it's good to mention, Leah, to add to Arnoud, that we, on the transportation modeling, we have done 2 pilot projects now. They have been finished and delivered to Evides in the Netherlands and to EVN in Austria. So we have experience, so we can run these. So it's not available as software yet, that's right, but we can, let's say, make the calculation, but we do this manually, let's say, instead of that the client can push the button, let's say we push the button. That's the difference.
Perfect. And what you're working on at the moment is to make that a manual, automated process as well.
Yeah, and that, exactly. And the first in our line on our roadmap is SI Rehab, had this risk model for distribution. That's the first in line. And when that one is available as software, we're going to step into the next one, which we haven't really decided yet. It also depends on what clients ask us. But that can be either the transport risk model, or maybe it will be we didn't talk today about the design software, but we are also working on software where you can almost fully automated calculate the design of the network. That can be very interesting to have as software. So we are we're not there yet. The first step is SI Rehab, the risk model, and we expect beginning 2025 to have that available as software, and then we're making the subsequent steps.
Perfect. Thank you, Ignaz. So just another good question from the audience. There is a lot of great innovation happening, and there are plenty of great ideas to solve problems. Where things tend to slow down is the implementation of the solution. Do any of the panel have lessons learned from the implementation of this tool? What do UK and Ireland companies need to think through when implementing to ensure a successful rollout? And that's for anybody to answer.
Okay. Flavio, do you want to? You have an answer?
It's a difficult, tricky question. So I completely agree with this problem. I can't give a solution, but I can witness that there is a huge problem to make a step forward from a POC to a deployment of a solution in all the network. So it's so easy for us to make POCs all around, but even if they are good, even if we found good results, it's so difficult to make the further step and widespread this solution in all the network. I don't know exactly why. I think that Ignaz told a very wise thing before, that asset management is a matter of all the company, not of an engineer or an office department. And I say that also innovative solutions are a matter of a company, because if they are relegated to an office, as it happens very frequently, it's impossible to go over a POC, even if it takes good results.
So then a key learning for you, Flavio, would be to ensure that you're sort of collaborating with a wide range of teams and not just focusing on a specific sort of end user.
Sure, at least it's what I see in my reality.
Absolutely. And Nino, any sort of learnings from your point of view for Oasen?
I think it's very important to have a sponsor in your company, or someone who wants a solution to improve his processes. Because when you don't have it, then it's a struggle. But when you have a sponsor and when you have the money in as budget, then it is not so difficult in our company. We are small and we have a dedicated asset management department that looks forward, that makes the savings of the money for the next years. And you have a good sponsor in your company that the main user, I believe, then there is a lot possible.
Yeah, and also think, Leah, what our experience is, we typically, our first connection with a new client is with the technical people, is with the asset manager, or sometimes it's more like the GIS, the data people. So it's not always the same. Nino, you are, let's say, on the innovation side. So sometimes it's more the innovation department that is making the first step. And then that's also why we offer this free demo. In the end, it's getting started. And if it's getting started and the first results come in and the results are used in discussions or in dialogues with other people within the company, then we are a slowly moving business. We all know. So we are very patient, and what we do is every time make a small step and present results, and the results then hopefully are being used, and then they are being re-asked for. Then the next annual budget comes up, and then we said, okay, well, yeah, we should do this again, because then we can sort of make a comparison. And so it's going really slowly, but as long as things continue to move, even slowly, then in the end, because then after 5 years, people said, why do you send this data manually every time to these guys? Can we just automate this? Yeah, of course we can. That's because technically it's relatively easy. There are multiple ways of connecting data sources to models and software. Technically it's not an issue. This is all about policies, about approval levels, about which is good, which we need, of course, in the world where we live in. We need those very strict policies. But there should be a balance, of course, in doing clever things on the one hand and being safe on the other hand. So our approach is we are very patient and making very small steps at a time, and accelerate when possible and when requested upon by a client. So, and of course, when the technical people start showing results, and when the results are being considered useful and really contributing to budgeting processes and to the increase of performance, then it reverses. The question reverses, and then it's why do we do this in this way? Let's embed this and let's go forward, and then it's relatively easy to install.
Perfect, thank you. And from the sort of supplier perspective, would you say there are any particular obstacles that you encountered when rolling this out in the various companies, and sort of what was done to overcome them?
Or did it all go quite well? Want to do it? Yes.
Sorry, go ahead.
Okay. Obstacles are sometimes the availability of data, but usually we manage to transfer various file types or connections into standardized data. So usually the main obstacle is the willingness to work together. And I think the sponsor that Nino mentioned, that's an important one, because a sponsor higher up in the organization can easily solve IT problems, give priority, and well, in the end,
sort of
in all
make
the
sure
projects,
the
every
project
problem got solved. Yes.
Yeah. Perfect.
I echo this. This is really, trust is the main obstacle. Technical stuff, in fact, we can always solve. Technically, we have never seen a technical problem that we haven't solved when we work closely with the client. So it's really about being trusted, and that, of course, is not easy. But that's why we sort of propose these small steps in building up the trust. Yeah.
Of course, perfect. Thank you so much. Okay, so another question from Jeremy. Do you consider the impact on the surrounding network risk when you are looking at very localized mains replacements? Anecdotally, people in the UK talk about local risk increasing when the short sections are replaced.
Yes, in the calculation of the risk score, we look at two types of effect. You have the probability of failure, which is statistically calculated and locally calculated. The effect of failure, it has two sides. The surrounding area, the directly surrounding, like the hospital example Ignas mentioned, but also the impact on the network. So when replacing a small part of the network, it might have a lot of dependencies and cause a lot of problems, and it is part of the risk score.
Perfect, thank you, Arnold. And did you have any sort of specific metrics in place when you were rolling out these projects to sort of evaluate the success of the project as they were being rolled out?
Yeah, it's a very good question, and in fact, it's one of our Achilles heels, because the asset management is typically is a process that takes years to actually have measurable results. It will take years because we replace pipes every once per. What is the replacement ratio? Average 1%, which means that it takes 100 years to replace all pipes. So it's really, we have done a calculation for Avides, one of our clients. They asked us to analyze the pipes that have been replaced as a consequence of the modeling. Is that area performing better than other areas? And statistically, we didn't manage to prove. You could see, if you would want to, you could see an improvement, but not statistically valid. So that is really tough. But what we do know is that the technical people at our clients, the asset managers, they know that this is this way of risk thinking and trying to use objective data rather than the expert judgment of the old chap who's 65 and who knows which pipe to replace. You replace this by a data-driven approach, which is more objective. So in fact, that is a process improvement. And having said so, of course, we have the number of leakages, we have customers' minutes lost, we have the average age of the network. These are all the metrics, non-revenue water ratio. These are all the metrics that we, in the end, contribute to. And also, what I start my presentation with, we are aware that we are just one of the 4 pillars in the reduction of non-revenue water. If excellent repair, if you have smart meters and you can identify a leakage within 2 hours, and 2 hours later there's a guy to fix it, that's a great way of reducing non-revenue water. But replacing the worst pipes is also a great way of reducing non-revenue water. So it's better. Maybe it's better. Maybe it's in the long term it's better. I agree. But on the short term, of course, I can imagine that fixing leakages is also appreciated as a good solution. So it's So the honest answer is it's not easy to prove that working with our software is beneficial tomorrow, and this is the ROI of 2 years and so on. That's not a sort of remark we can make, but still we see that the Dutch clients continue to come back to us with new questions. They ask us. We have an annual meeting with the BestNet clients where they decide upon the roadmap developments of next year, so how we improve the software. So there's a lot of the technical people love to work with this software, and especially because they have influence in the development of the software. It's more those quite intangible upsides of working with these kinds of solutions.
Perfect, thanks, Ignas. And kind of related to that, so what is the ROI of these kind of services?
So that's a difficult question to answer. But when you look at, we feel that, for example, like you say, Nino, the goal to go back with 1% point from 4.7 back to 3.7, or in your case, Flavio, from 68, you want to reduce with 1/3, so even 20% points of reduction of non-revenue water. And of course, water is very cheap. So that's a problem in this perspective. But still, if you calculate the loss of water that you are saving in terms of water, in terms of energy, in terms of chemicals, you can make and you manage to save 1%. You can in 1 year earn back the investment in our software. But of course, it's not easy to really strictly tell that it's because of our software that you reduce the non-revenue water with 1%. So, but we think you can really, in a couple of years' time, you are really in control of the replacement of your pipes in the network, of your annual budgets. And yes, you will see reduction of non-revenue water within a few years' time. And already with the saved water, the energy component, the chemical component, you will already earn back the money. But also we are aware that our clients, they want to be in control. They want to tell their shareholder, and also in the UK, I'm aware more and more the public demands from utility that they are performing and that they controlling, or at least doing their best to reduce when you have droughts on one hand and 40% of leakage on the other end. How do you explain? So the public is more and more demanding, and by applying these kinds of methods, you can tell your clients, you give us a lot of money, but we have calculated that the money that you are spending is invested optimally and accountably. Yeah, what's the value of accountable and optimal decisions? Yeah, I think it's a lot. There's a lot of value in there.
Absolutely. Thank you, Ignaz. So a question from Oliver. Does the risk score include any measure of potential for pollution risk? In the UK, we also have to be wary of the risk to watercourses from chlorinated water discharges to the environment.
No, we didn't take that into account yet. But I think you could do it combining the layout of the watercourses, and we do calculate the potential volume lost, and I think you can quantify it by combining those parameters. We didn't include it, but it seems like a possible effect parameter.
Yeah, I agree.
So would you say that your sort of technology would be adjustable if the sort of company in the UK was wanting to focus on pollution risk, you'd be able to kind of adjust this technology to kind of map that out as well as the asset management side of it?
Yes, I think it would be possible to include that parameter.
Amazing, perfect. I know that's a big focus for our water companies in the UK at the moment, so I'm sure they'll be pleased to hear that. Okay, perfect. So, Ignaz, just a bit of a general question. What's the sort of track record of Spatial Insight with these kind of projects?
Yeah, so we have just welcomed the 10 out of the 10 Dutch water utilities working with us. So we are serving the complete Dutch drinking water sector. So that is a track record. For Oasen, Efides, WML, we are, I dare to say, we are their main supplier in the services and in supporting the asset manager with software. These are our biggest clients, and they are really relying upon, we are really embedded, our software is embedded in their asset management processes. Track record, we are serving Italian clients, Austrian, Belgian clients in the last 2 years. So we are really, and it has been important for us to, of course, we are very lucky with Flavio that he wanted to work with us based upon the European funding scheme, the PNR. But it's not an exception, because we are now working in Austria. We'll start to work soon, I need to say, in Belgium. And that is, we believe that is a sort of proof that we can, that this is not just some network exercise in the Netherlands. We are really adding value in multiple markets. And on the other hand, it's not really strange, because the centralized water system, as we know it started all in London with John Snow in 1854, but the centralized water supply system is in the developed countries. It's everywhere. It's 100 up to 150 years old. All the aging infrastructure, it's everywhere. We are saving and drought, climate change. These are global issues. So. There's no reason why what we can do in the best performing distribution networks in the Netherlands, why we cannot do this internationally. So, and that's also, of course, we're very pleased to get to know better the UK market, because just the example that you were giving, Leah, it's very important for us to know the focus of the British utilities, to be able to address and to adopt and to tailor our solutions toward these focus areas. But we are, as I said, we are really we love new stuff. Our challenge is to do the repeating stuff. That's our bigger challenge, because new stuff and new problems we love. We're too much engineers to love to do new things. So yeah, we can't wait to actually, well, take up these. And also, I've no idea in what way utilities tend to join forces in these kinds of topics. But if so, that's also what we do with BestNet. BestNet was a co-development of 4 drinking water utilities in the Netherlands, and we are really pleased when it comes to such an water quality discharge issue. If 2 or 3 or 4 utilities sort of team up together, say, well, we all have this problem, and let's do a joint pilot or so, a joint development. We are really pleased to. It's good for us. It's good for the utilities, because then you know that you're not the one-off, but that more utilities tend to use the software, and then the chance that it will actually survive after a POC or a pilot is bigger. So those kind of joint, in the Netherlands is really, we are a small country, these utilities know each other well, but they are really used to team up in those kinds of developments. So yeah, very pleased to work in that way in the UK as well, in Ireland.
Amazing. That brings to mind, actually, I know we recently did actually a showcase about collaboration between UK water companies to create a sort of open data set around sewer defects and things like that. Is that like material that Spatial Insight could use for their technology?
Yeah, well, we're not into sewers, so we're really, today we have been speaking about drinking water systems, drinking water supply. That's where our domain and expertise is focusing on. But in general, yes, if larger data sets mean better results. On the other hand, we are aware that when it comes to the responsibilities in the asset management process, typically it's organized within these utilities. So from a mathematical perspective, it may be attractive to sort of increase the data sets, but when it comes to serving a utility and solving a problem, then typically the utility, well, borders are the right ones to follow.
Absolutely. Perfect. Thank you, Ignaz. So Nino, from your perspective, was there anything that you Oasen did in particular to sort of ready their teams for the use of this technology when you were rolling out the project? Did you have any sort of specific training in place, or any sort of particular communications that were needed to involve the teams that would be using this technology?
Yeah, it's I'm thinking about, we started 8 years ago. With Julian, your colleague, was working at our company, and we took a model from the Microsoft suite, and we involved University of Nyenrode, and in 5 days we had a model that predicted pipeline burst. And so long, and then Julian left our company. He went to Spatial Insight, and they develop it. So we are, we know this kind of products for many years already. So it was for us not a problem to implement it.
It's quite a simple process.
And now you have the data warehouse, the ADI, and make it more professionally, but the methods we use already for many years. So it was not so difficult for us.
And it's good to add to this that Jurjen, the one you're talking about, is currently in Ancona in Italy, giving a 3 days training to the staff of Viva Servizi. And coming week, he also will be visiting GSP to do a 2 days training course. So there we do a general asset management training course in getting everyone involved in the asset management process up to speed in general and about asset management. But then, of course, we will be focusing in one of those sessions on the data-driven asset management as well. So that is how we can support utilities when they want to get the team up to speed. We can provide those trainings.
Perfect. Thank you, Ignaz. And Adrian just wanted to ask as well, does the raw data need to be in a particular format to enter your system?
Arnoud, for you?
No. We in one of the slides you saw the Lego base plate. That is the standardized data model we use for our analysis. But the step before is to translate the data from any, well, a GIS-based format, but whether it's in a database or in a GeoPackage or a shapefile, we can always work with it. Of course, that's in the manual. If you want to automate over time, then you would have to have an ETL process to transform the data. But to get started, it's not an issue.
Perfect. Thank you, Arnold. And just to wrap up on a exciting note, so Ignaz, is there what are the next sort of steps for Spatial Insight? What are your goals for the coming years?
Yeah, so in the coming years, we are in the middle of, in fact, of two transitions. We are in a transition from a data science consultancy towards a software company. So we will be focusing in the coming 2-3 years on all these algorithms that we already have developed and still developing to turn them into software that can be used by a client, him or herself. That is one development that we will continue. We are also still growing, so we will also, our organization needs, when growing an organization, new challenges come up that we need to address. But also we see that we are expanding we are exploring the responsibilities of the asset manager more and more. So now we are in this, well, decision making, picking the worst pipes. But then the next step is this alignment with others. The next step is designing. So which pipe diameter should be installed? What's the optimal pipe diameter for the tertiary networks? What is the optimal geometry? So where should we put even location, automatic location calculations? But we're also in portfolio management now. We are doing a project where a client in the Netherlands, with the handover from the asset manager to the execution department, so the people who need to organize the works out there, they need to handle the project that they are being handed over with. And so you see that where the responsibilities of the asset manager, we try to cover in all of the steps of his responsibilities, we try to add software. But but like you say here, Leah, the example from the UK with the data quality in Italy, we have a request from the other client about the more exact calculation of the actual water losses. So there's more the hydraulic, including the hydraulic calculations into the asset management modeling, and so that's also a field where we're expanding.
Perfect, amazing. Thank you, Ignaz, and thank you to all of the panel today for your great answers to these questions. I think that pretty much brings us to the end of today's session. So thank you to everybody who has taken time out of their day to join us today. We hope you found it valuable and engaging. Thank you also to the team from Spatial Insight, Oasen and BIM GSP. It's been so great to have you here and to work with you all on today's session. And I think it was a really great and informative presentation that you put together, so thank you. I believe my colleague Kira, thank you to Hein as well for joining us at the beginning. That was really great of you to step in like that when we were out of CEOs, so thank you, Hein. And I believe my colleague Chiara has just popped a poll in the chat about today's session, so please do take a moment to just give us some feedback. We do find it extremely valuable for how we shape these sessions moving forwards. As said at the beginning, we'll be posting the recording of today's session on our platform along with the case study, and that should be available within the next week, if not sooner. Any questions that haven't been answered today during today's event, you can either email any further questions to myself or Ignaz or any of the team involved today, and anything that hasn't been answered we'll upload alongside the case study as well. So thank you again to everyone for coming, and I hope you enjoy the rest of your days. Thank you. Bye.
Thank you.
Thank you.
Thank you.
Goodbye.
Bye.
Bye.